Hi everyone, welcome to my video where today we're talking about proofs and they are all about angle relationships. Before we dive deep into those proofs, I have a bunch of postulates, theorems, and special just situations, axioms, did I mention theorems? Yes, that we need to make sure we have in our notes and that we are aware of because they are things that we have not actually used yet in any of our proofs. So brand new things that we need to be able to put in our toolbox of reasons and things that actually help us then go from one step to the next in any given proof. So the first one here is the angle addition postulate. So previously we talked about the segment addition postulate, where if you have a segment with a point that's in between two other points, then you can say that the two parts are equal to the sum of make the whole. The same thing is true for an angle addition postulate. So it says if R is in the interior of angle PQS, I'm actually just going to make a little sketch here. Okay, so PQS. And so if R is somewhere in the interior of angle PQS, then the measure of PQR, so the measure of this first angle plus the measure of RQS would be equal to the entire angle of PQS. So we needed the segment addition of postulate a lot to talk about the two parts equaling the whole. The same thing is true for angles. Two angles within a bigger angle should add up to the sum of the measure of the biggest angle. Now a new theorem, supplement theorem. When you see the word supplement, you should be thinking of supplementary. And supplementary is, of course, about 180 degrees. But look at what this theorem is specifically saying. It says if two angles form a linear pair. So if two angles form a linear pair, and remember a linear pair is a set of two adjacent angles that make a straight line, then they are supplementary angles. So the moment you are told that two angles make a linear pair, then you're going to be able to say that they are supplementary to each other. Okay, so linear pair to supplementary is the supplement theorem. Complement theorem, it says if the non-common sides of two adjacent angles form a right angle. So if the two non-common sides of two angles form a right angle, so this is a common side of these two angles here, but this ray, my vertical ray and my horizontal ray here, make a right angle, then the angles are complementary. So if a right angle is formed, then those angles are complementary to each other, and it goes in that order. Once we're able to make those statements, like about supplementary angles, then we can talk about their measures being equal to 180, and same thing for complementary. Once you are told you have a right angle, two angles form a right angle, then we can say they're complementary, and then we can talk about their measures being equal to 90. Everything has a very specific flow and order, and we have to make sure we follow that order when we are doing our proofs. Congruent Supplements Theorem. Angles supplement to the same angle, or congruent angles are congruent. So here is what this is saying. Angles supplement to the same angle. So if I have an angle here is 100, and then another angle here is 80, very bad drawings, and I have another angle here that's also 100. This theorem is basically saying angles supplement to the same angle. So this angle of 100 is supplementary to this angle 180. And this angle of 100 is also supplementary to this angle 80. That means that these two angles must be congruent to each other. So when we're talking about angles being supplementary, we're always knowing the measure. The measure of the sum is 180. But then that means that if two angles are supplementary to the same angle, then that means that those angles not only have measures that are equal, but they're also congruent to each other. The same thing is true for congruent complements. So if I have a 40-degree angle and a 50-degree angle, and then another 40-degree angle, if the 40s are both if the 40s are both complementary to the 50, then that means that those two 40-degree angles must be congruent to each other. Seems like we should know that. It's not like it's something that's a brand new idea, but we officially have a theorem to state that. Vertical angles theorem. We previously talked about vertical angles, Vertical angles are created by two intersecting lines, and the vertical angles are the angles that are directly opposite each other. They are congruent. And it says if two angles are vertical angles, then they are congruent. That's officially now in our notes as a theorem. It's called vertical angles theorem. And we're going to definitely be using that. So opposite angles, you'll notice they share the same vertex. They share the same lines. They're just directly opposite from each other. Here are some theorems of things that we just know this, but we're now officially being able to state them. And these sentences are sentences that you would actually put into your proof as reasons. And technically, you can use any of the statement sentences that we've already seen, or you can use the theorem for its name. These are just more statements. So a statement is perpendicular lines intersect to form four right angles. And that is just true. Because when you think about two lines that are perpendicular to each other, they intersect and they form all four right angles. So that is just a statement. And that could be a very important statement that we need in a proof to go to the next step. And then it would lead us to where we need to be. All right angles are congruent. So if I have perpendicular lines, they form four right angles. I would then be able to say, okay, well, all right angles are congruent. That's just something that we know, but we can officially say it in a proof. Perpendicular lines form congruent adjacent angles. So not only are they congruent to each other, but everything that's adjacent means next to, okay, which also still plays off of those previous two statements. If two angles are congruent and supplementary, then each angle is a right angle. So if I have two angles that add up to 180 and they are congruent to each other, well, that means each one must be a right angle, which makes sense because then they would both be 90. Again, something that we already would know, but we're just making that official statement now. And now if two congruent angles form a linear pair, then they must be right angles. And that also should make sense. All right, let's jump into some proofs now. Ready? Okay, I'm going to zoom my screen out just a little bit so we can see the full proof. Okay, given angle ABC and angle CBD form a right angle. The measure of angle ABC is equal to 5x and the measure of angle CBD is equal to 4x. Prove that x is equal to 10. So this is very interesting. We're given information about two angles forming a right angle. We had a bunch of statements in our previous slide that talked about angles being a right angle and what we do with them. And then we're told about the measures. So we're going to need to game plan this. We need to make sure we include our given. We talk about what it means to be a right angle, what the measure of a right angle is, and then we're going to definitely need to use some substitution to plug in the values for the two angles and have them set equal to the measure of that right angle, and then we're able to solve. So our first statement is always the given. And again, you can list part of the given and then use it to go a couple steps, list another part of the given and go a couple steps, or you can list it all in one. It really depends on how you feel like you can explain the process. So I already went ahead and I listed everything here in the given. The next thing that I would need to say is that angle ABC and angle CBD are complementary. There's a process. So once you talk about them being a right angle, then you can talk about them being complementary. So given the right angle is like step one, and then step two, you can talk about them being complementary to each other. And that is simply because of the complementary angles theorem. If two angles form a right angle, then I know that those angles are complementary to each other. Now that I say that they're complementary to each other, I can go ahead and say that the measures should add up to 90 degrees. So look at that process. You go from what type of angle it's a right angle to saying, okay, well then they're complementary, to then talking about them talking about the sum being 90. And that order is very, very important. That is the definition of what complementary angles are. So if I say two angles are complementary, I'm then going to be able to say that their measures should add up to 90. So the complementary angles theorem goes from a right angle to saying they're complementary, and then saying they're complementary to being equal to 90 is the definition of complementary angles. Now, since I know what the measure of angle ABC and the measure of angle CBD are equal to, I can go ahead and substitute those in. Okay, measure of angle ABC is 5x, measure of angle CBD is 4x. I can then use substitution to combine my like terms. Remember, substitution gets used two different ways, basically, to replace values that they know they're equal to, and also basically to combine like terms. And then I would be able to say that x equals 10, and that's me using the division property of equality if I was to divide both sides by 9. Okay, so I made a big deal about this because it's really, really important to follow along. So right angle, then you state they're complementary, and then you can state that they have a sum of 90. Problem number 2. Given the measure of angle ABC and angle CBD form a linear pair. I'm going to zoom my screen out a little bit, and the reason why I did these problems side by side is for a specific reason, so you can see that the order incredibly matters here. We're given the measure of angle ABC is 5x and the measure of angle CBD is 4x. So I didn't even change the expressions, but I'm talking about a completely different figure. Okay, so I listed the given. I know I'm going to eventually need to prove that x is equal to 20. So here is this process. You go from stating they are a linear pair, just like this was stated as a right angle, to the next step, which is then saying that angle ABC and angle CBD are supplementary. And that's what the supplementary angles theorem is. So going from a linear pair to then saying they are supplementary goes in that order. So notice, right angle goes to complementary, goes to 90. Linear pair goes to supplementary. Okay, we say they're supplementary by the supplementary angles theorem. And then look what happened next here. I said that their measures added up to get 90. So here you're going to be able to tell, well, I'm going to do the same thing. I'm going to say that these measures add up to 180, and that is the definition of supplementary angles. Okay, so this order is really, really important. Then we're going to go ahead and we're going to use substitution. So it's 5x plus 4x equals 180. Just like we did in the previous proof, we're going to use substitution again, call it 9x equals 180. And then using division property of equality, we can say x is equal to 20. So these two proofs are incredibly important in kind of setting the stage for what it looks like to really have everything in order, and we're using the appropriate theorems and definitions. Okay, problem number 3. Problem number 3, it says we are given that angle 1 is congruent to angle 3. And I'm going to just go ahead and mark this up so I can visually see what I'm working with. We need to prove, and I'm going to put that in red, that angle 2 is congruent to angle 4. Okay, so we are given that angle 1 is congruent to angle 3. Now, the only thing we really know about angles right now are linear pairs, which I don't see, right angles, which I don't see, but we are given some vertical angles here. And there's a couple different ways we could do this proof, guys, but I'm going to obviously show you one of the ways and steps. If I know angle 1 is congruent to angle 3, that's great. But what else do I know about angle 1? I know that angle 1 is congruent to angle 2, right? Because those are vertical angles. I also know that angle 3 is congruent to angle 4 because those are vertical angles. So I can say angle 1 and angle 2, angle 3 and angle 4 are vertical angles. And that is the definition of what vertical angles are. Okay? They are vertical angles because they're directly across from each other. So then if they are vertical angles from each other, I can say angle 1 is congruent to angle 2 and angle 3 is congruent to angle 4 by the vertical angles theorem. Okay, so the statement I just did here, I'm just defining the fact that I know that they're vertical angles. And then in this third step, I'm saying, well, hey, if they're vertical angles, I can say that they're congruent to each other, that each pair is congruent. So now let's take a look. We're given that angle 1 is congruent to angle 3. We're told angle 1 is congruent to angle 2 and angle 3 is congruent to angle 1. So we can say angle 2 is congruent to angle 3. Now think about why we can say this. If angle 1 is congruent to 3 angle 1 is congruent to 2 and 3 is congruent to 4, then by that transitive property, okay, of angle 1 being congruent to angle 3 and angle 1 being congruent to angle 2, okay, notice they have angle 1 in common, I can say that those two angles are congruent to each other. Now what I want to prove is that angle 2 is congruent to angle 4. Well, let's take a look. Angle 3, we have listed here, is congruent to angle 4. So if angle 2 is congruent to angle 3 and angle 3 is congruent to angle 4, then I would be able to say that angle 2 is congruent to angle 4 also by the transitive property. Okay. Number 4, angle DBE and angle EBC form a right angle. So immediately you should be thinking, okay, if they form a right angle, then that means that their measures are complementary, and that they are complementary angles, and if they're complementary angles, then they add up to 90. Then I'm also told here angle ABD and angle DBE are complementary. So now if I'm already told they're complementary, I'm going to be able to say that their measure is equal to 90. Okay, we need to prove that angle ABD, so this angle here, is congruent to angle EBC. All right, and actually, we probably don't even need to deal with 90 because we're just talking about angles being congruent to each other. So let's take a look. Ready? Angle DBE and EBC form a right angle. Okay, angle DBE and EBC form a right angle. And then I'm told that angle ABD and angle DBE are complementary. So these are complementary. So I know these two angles add up to 90. I'm not going to need to put that in my proof, but I'm just putting them together. They're complements to each other. And I'm told that these two angles here form a right angle. So if these two angles here form a right angle, I'm going to be able to say that these two angles are also complementary to each other. And then if they are complementary to each other, then I'm going to be able to say that this angle and this angle have to be congruent to each other because we notice that they're actually complementary to this same middle angle here. So I'm going to go ahead and I'm going to use the first part about them forming a right angle, and I'm going to say that those two angles are complementary. Notice like the overlap here. ABD and DBE are complementary. DBE and EBC are complementary. So if I have a pair of angles that are complementary and another pair of angles that are complementary, and I notice that they share an angle together, it's this middle angle here, then I would be able to say that angle ABD and angle EBC, which is what I'm trying to prove, are congruent to each other, and that was that special congruent complements theorem, where if you have two angles that are complementary to the same angle, then that means that those two angles must be congruent to each other. And using a measurement example would be if I have 50 and 50 and then 40, well, 50 and 40 are complementary, that 40 and this 50 are complementary, and then clearly those 50s are equal to each other, and if they're equal, then they are congruent. Okay, I've got two more proofs from this set for us. Given angle BAD is congruent to angle EAC. So BAD is congruent to angle EAC. All right. Prove that angle BAC, so this angle here, prove that this red angle is congruent to this angle here. All right, so this should kind of remind us about using the segment addition postulate in the previous lesson, where you had two segments and then they had a little overlap section in the middle. And what we wanted to do is basically say, well, hey, this angle is broken up into two separate angles by, now it's the angle addition postulate, and this bigger angle, which is here, is broken up into two smaller angles. They share a smaller angle. So if I subtract the measure of that smaller angle out from both of the bigger angles, then I'm going to be left with the two smaller angles being equal to each other. Okay, so it's going to be very familiar and very similar to the segment addition postulate, but instead we're using angles. So let's kind of think about that game plan as we go ahead and write this. So after I state that these two angles are congruent to each other, we should remember that we usually, and especially if we're going to talk about measures, we go ahead later on in the proof, we go ahead and we say that their measures are equal. And that's always your definition of congruent angles, or you can call it congruence theorem of angles. So now, once I say that these two green angles, their measures are equal to each other, I want to make sure I make that statement about the two smaller angles equaling the bigger angle that I'm creating. So this angle BAC, so the measure of angle BAD is equal to the measure of angle BAC plus the measure of angle CAD. So I'm breaking it up. What might be helpful here too, guys, is I'm going to just recolor this in. So this statement here is saying that the entire angle BAD, okay, is composed of this little angle plus this angle. So that's the first statement that I'm making there. And then I can say the same thing for EAC. So the measure of angle EAC, and I'm just going to use another color, the measure of angle EAC is made up of these two smaller angles being added up. So it's the measure of angle EAD plus the measure of angle CAD. So I've got the bigger angle being broken up into two smaller angles, and I have these statements here. Well, now think about what happens. We said that the measure of angle BAD was equal to the measure of angle EAC, and I know what BAD is equal to. It's equal to all of this. And I know what EAC, the measure of EAC is equal to. It's equal to all of this. So I think you can tell what's going to happen now. We're going to be able to make this statement by using substitution, that the measure of angle BAC plus the measure of angle CAD is then equal to the measure of angle EAD plus the measure of angle CAD. Now, we talked about the fact that these two bigger angles have an overlap of that middle angle. And so you should notice that the measure of angle CAD is in both of those statements. It's on both sides of your equation, rather. So we're going to be able to subtract that from both sides and just be left with the measure of angle BAC is equal to the measure of angle EAD, and that's your subtraction property of equality. Look what I need to prove. I need to prove that those two angles are congruent to each other. So we know that going from the measure to their congruent statement is just the definition of congruent angles, and we are done. So again, I know I mentioned this a couple times before. This is just like using the segment addition postulate, but now it's angle addition postulate instead. Okay, given ray BC bisects angle ABD. So let's take a look at this. So BC, this ray BC bisects ABD, this entire angle here. So that's what I know so far. I need to prove that the measure of angle CBD, so this angle here, is equal to the measure of angle FBE. Okay, it's like, what are we doing with this, right? But we have to use our given and then see where it leads us. So if I say that a ray bisects an angle, the only thing we really can say next is, okay, well then angle ABC is congruent to angle CBD. And that's just the definition of an angle bisector. All right. So now notice that one of the angles that we just talked about being congruent is part of one of the angles we need to prove. But so far I have nothing to do with FBE. But let's look at this diagram. We're now saying these two angles are congruent to each other. We need to somehow prove that the measures of these angles are equal to each other. Well, if these are congruent to each other, and I notice here that this angle ABC is actually a vertical angle to FBE, I can then say that these two angles are congruent to each other from vertical angles theorem. And then if these two angles are congruent to each other by vertical angles, and these two angles are congruent to each other, which means their measures are equal, I would then be able to probably match these up by using the transitive property. I know that's a mouthful, but let's see where this brings us. So I would be able to say that, okay, angle ABC and angle FBE are vertical angles. And that's, again, your definition of vertical angles. We saw that in a previous proof. And since they are vertical angles, then I can say that they are congruent to each other, which is our vertical angles theorem. So now, if ABC is congruent to CBD, and ABC is congruent to FBE, angle FBE, okay, then I can say that angle CBD is congruent to angle FBE by the transitive property. And since they are congruent to each other by the transitive property, then I'd be able to do what I need to prove and say their measures are equal by the definition of congruent angles. So definitely, guys, the more we do proofs, the more ideas like this are going to pop up. If this is the first time you're looking at any proofs like this, then yes, you might say, I would have never even looked at that next step or even thought of that next step. But I promise you, the more proofs we do, the more these ideas just kind of get put into your toolbox of reasons, and then you know how to go on to the next step. Okay. I've got two last proofs here for you. It says find the measure of each number, I'm sorry, not proofs, just problems. Find the measure of each numbered angle and cite the theorem that justifies it. So here I have angle 3 and angle 4. I am told what those measures are equal to. This should pop up right into our head that they are vertical angles. So because of the vertical angles theorem, they are congruent to each other, which then means that their measures are equal, and you would be able to set them equal to each other. Okay, and so the measure of angle 3 would be equal to the measure of angle 4. You would go ahead and do your basic algebra and get that x equals 2. You would then substitute 2 back in. So 5 times 2 is 10, plus 2 is 12. And then, of course, the measure of angle 4 should get you the same thing if you substitute that 2 in. 8 times 2 is 16, and then 16 minus 4 is also 12. Looking here, we should see that we have a right angle. So then the measure of angle 6 and 7, we should see form a right angle. So that is going to be your complementary angles theorem. When two angles form a right angle, then they're complementary to each other. If they're complementary to each other, they would add up to 90. So x plus 5, which is the measure of angle 6, plus 7x, which is the measure of angle 7, would add up to 90. I would do just my basic calculations, and you end up getting 10.625 for x. If I wanted to know the angle measure, though, I would, of course, need to go back and plug that in, and I would be able to get all of my actual measures. This last one, guys, is I see that these two angles form a straight line, which is a linear pair. If it's a linear pair, then I know they're supplementary, so that's your supplementary angles theorem, which means I would add these up to 180. I would use my good algebra skills to solve for x, and once I get x equals 28, I would be able to substitute those back in for x, for my angles rather, to find my angle measures of 35 and 145. I hope this video was helpful for you. Thank you so much for watching. Bye.